So this is the last part of paper E on the mechanics. A cyclist of mass 80 kilograms is travelling with speed 18 meters per second. The cyclist stops pedalling and comes to rest without braking due to resistance forces totaling 120 newtons. So what we need to pick up on here as we read the question is that the forces are constant, therefore acceleration is constant. So in a SUVAT kind of context, we've also got mass force. So let's have a look at this then. So we've got a cyclist, excuse my diagram, 80 kilograms. It's got an initial speed u. So u equals 18 meters per second. Sometime later, it comes to rest. Find how long it takes for a cyclist to stop. So v is equal to 0. Here t equals 0. We don't know the time when it comes to rest. So there's got to be an acceleration. It's going to have a negative value, the acceleration, but it's constant. And we've got a resistance force of 120 newtons. So apply N2, we've got mass and forces, so that's a big sign that we're going to need to apply N2 in the direction of the initial motion. So we've got direction sort of increasing x really is a better way of thinking of it. So we've got forces minus 120 is equal to its mass times the acceleration. That's using F equals ma. So A equals negative 120 over 80, which is negative 3 over 2 meters per second squared. So we've got the acceleration. So we can now use our SUVAT to find how long, the time it takes. So constant acceleration. We want t. We've got u equals 18, we've got v equals 0, and we've got a equals negative 3 over 2. So au, v and t, that suggests we should use v equals u plus at. So v is 0, u is 18, plus acceleration is negative 3 over 2 times t. So add it across to make it positive, plus 3 over 2t equals 18, multiply by the denominator, 3t equals 36, as he writes 8, pretty stupid. There we go, 36, divide by 3, so it's 12 seconds is how long it takes for cyclists to stop. Find the distance the cyclist travels before stopping. So I assume it's in this time. So B, constant acceleration again, acknowledge it. T is equal to 12. S is the distance travelling that we need to find. Go back, use the information in the question if possible. So U equals 18, U equals 18, and V equals 0. You could use something with A in if you wanted to, it doesn't matter particularly, but that works fairly well. So S equals, perhaps would be better not using T because that was a calculated value, but so was the acceleration, to be fair. So if you're going to use a calculated value, it doesn't matter which one you use particularly, although T is further down the working. So we've got S equals U plus V times T over 2. Substitute in the values. 18 plus 0 times 12 over 2. 6 times 18 is 60, plus 48 is 108 metres. There are other ways of doing that. You could have used v squared equals u squared plus 2as and you'd get to the same answer. Part C. Describe one limitation of the pot model. Well, the resistance forces are unlikely to be constant. We sort of assumed it's a particle to do the question to have constant forces. So I would say resistive forces will not be constant. And that's that one done as well.